Hello everyone, today we're going to be learning about the summation of arithmetic and geometric series and sequences with word problems. I know that sounds really exciting. I know all of you are so happy that we're going to be doing this. So let's get started. Alright, so before we dive into this lesson, first thing we need to talk about is again the formulas that we should already know for this unit. Okay, so you need to know your arithmetic sequence. Okay, so arithmetic sequence, that's when we're just finding like the last term or the first term of a sequence. Okay, a of n, the last term of the sequence, equals a1, first term, plus n being the number of terms in the sequence, and your d is your distance, what you're adding to the thing every single time you go up the sequence. Okay. Now, when we come to a series, remember, series basically means summation. We're adding. So we're going to add all the pieces of the sequence together. So S of n, your total of the series, or the sequence, is equal to n, the number of terms in the sequence. A of 1 is the first term, A of n is the last term, and you're dividing all that by 2. Now when it comes to geometric, remember geometric, the difference between arithmetic and geometric, arithmetic we're adding every single time, geometric we're multiplying or dividing every single time. Okay, so if we do a geometric sequence as A of n, the last term of the sequence, equaling A1, the first term of the sequence, times R, which is the rate, raised to the n minus 1th power. Okay. And then again, the series, the adding up of all the pieces in the sequence, our summation or total of the sequence is equal to the first term times 1 minus the rate raised to the number of terms power, all divided by 1 minus the rate itself. Now again, with any type of word problem, folks, the first thing we have to do is you need to read the stupid thing. You need to understand what this thing's asking you, what you're looking for, etc., 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 etc. All right? So, Rosalind decided to make weekly deposits into her money marketing account, increasing the amount by $3 each week. If she deposits $50 the first week, how much will she have deposited in the 12th week? And how much will she have deposited altogether at the end of 12 weeks? Alright, so we have somebody trying to save some money. Not a bad idea. Okay. So, first thing we have to figure out is this arithmetic or is it geometric? Are we adding to it every single time? Or are we multiplying to it every single time? Multiplying by a rate. In this case, because we are adding $3 every week, that is going to be an arithmetic function. Okay? Now, we also have to realize that this is a two-part problem here. Whoops. Getting a little ahead of myself. There we go. Alright, this is a two-part problem, folks, because of the fact that not only does it ask me how much she will be depositing in the 12th week. That's the A of n by doing a simple arithmetic function. It's also then asking me how much altogether would she have added to this account after the 12 weeks are done. Okay, so we have a two-part problem here. Alright, so let's split this down the middle here. So, whoops. So we can do our two-part problem. Alright. Alright, so here we go. We got to start with the first part. We have to figure out A of n. They want to know what was deposited in the account on the 12th week. Okay? So that's our simple arithmetic function. So if you remember, arithmetic is an equaling a1 plus parenthesis n minus 1 times d. Okay? So again, if you don't remember the pieces, the A of n is the last term of the sequence. That's what we're going to be looking for here. A of 1 is the first term of the sequence. The N is the number of pieces in the sequence. In this case, we're going 12 weeks, so our N will be 12. And D is our distance, what we're adding to this thing every time we go up the sequence, in this case 3. Okay, so let's identify our pieces. Okay, our A of N, again, we're going to do A of 12. I don't know what that is right now, so we're going to be looking for that. All right. We know A of 1, what we started with. We started with 50 bucks in the account. Okay. We know the distance. We know distance, she's adding $3 to the account each additional week. Okay. So we now know all this. So let's start doing our math out and figure out what we need to do here. So I'm going to shrink the screen down just a smidge. There we go. So I have a little more room here. All right. So here we go. So let's start with our function. A of 12 equaling A of 1, which is going to be 50, plus number of terms is 12, minus 1, and our distance is 3. Alright, so we're just substituting in. Now we're going to do our math now. So again, I'm going to start in the parenthesis, of course. So A of 12 equals 50 plus, it's going to be 11, because 12 minus 1 is 11, times 3. Alright, now, let's multiply. So we're going to multiply 3 and 11. So A of 12 equals 50 plus 33. And then to finish, add that together, we're going to get 83. So that means in the 12th week, she deposited $83 in the account. So this is the answer for part 1. How much did she deposit on the 12th week? She was putting in $83. Okay, second part of this question is now asking me, all right, how much in total has she deposited since all this started? Okay, so now we have to figure out, and that's our summation. Okay, so that's a series thing. So we're now using the formula S of n equaling n times A1 plus AN, all divided by 2. All right. All right, so here we go. Let's start substituting in. Normal. Sorry. My cat stepped across the screen. There we go. All better. All right, so here we go. So we're going to go S of 12 is equal to 12 times. My first term of the sequence is 50. My last term of the sequence is going to be 83. That's what we deposited on the 12th week. And that's all divided by 2. All right. So now we break out our handy-dandy calculators. So S of 12 is equal to 12 times 50 plus 83. So we do our 50 plus 83. And we get 133. Oh, that looks awful. Let me try that again. Can't blame the cat for that one, can I? 133 divided by 2. Okay. So let's take our 133 divided by 2. So S of 12 is equal to 12 times. We're going to have 66.5. And I think most of you know what's happening next. We're going to then times that answer by the 12. So, after 12 weeks, and depositing, starting with 50 bucks, 12 weeks later, adding $3 each additional week that you're putting in, she has saved a total of $798. That's pretty good. So, there's that one. So there's question 1. Alright, question 2. Now again, first thing we're going to do, it's a word problem, so we have to read the stupid thing and figure out what's going on here. Okay? So here we go. So a family drove 729 miles on the first day of their vacation. Each day thereafter, they drove 2/3 the distance that they covered the previous day. How many miles did they drive on the 7th day of their vacation? Then also, how many miles did they drive altogether during these 7 days? Now, with something like this, again, we have to start by figuring, is this arithmetic or is it geometric? Now, my dead indicator is going to be this component right here. I have a rate. They're starting with the 729, and they're telling you after that, we're going to do 2/3 of that every single day thereafter. That right there is a rate. And anytime you're dealing with rate, that is telling you you are dealing with a geometric. So kind of like a dead giveaway. If you see a fraction, most likely you are dealing with geometric. Okay? Alright, so but again, this is also, like we said earlier, this is a 2-part question. We have the question, how many miles did they travel on the 7th day? Then we also have the second part of the question that says, well, how many miles did they drive altogether? Oops, hey. During that during those 7 days. All right, so let me split this. We're gonna have to split this in half. All right. So, again, realizing we are dealing with a geometric, we're going to use our geometric formula that says A of n equals A1 times the rate raised to the n minus 1th power. Okay, remember, A of n is going to represent the last term of the sequence. Our A of 1 represents the first term of the sequence. Our R is the rate. And again, n is the number of terms in the sequence. All right, so here we go. Let's start filling this thing in. Okay, so we're going to find A of 7 first. We have to find the last term of the sequence because they want to know how many miles did they drive on the 7th day. Okay, so let's begin. So A of 7 equals the first term. They went 729 miles on the first day. No, that looks awful. I'll fix that. Times my rate 2/3 thereafter. Every day thereafter, they go 2/3 that distance. And we do 7 days minus 1. So there's our formula. Now, obviously, order of operations says we're going to start with that exponent first. So A to the 7th, A of 7 equals 729 times 2/3 raised to the 6th. Let me get rid of that a little bit. I guess I can't. All right, whatever. So it's going to go to the 6th. All right, so now we have to do 2/3 to 6th power. So again, on your calculators, you open a parenthesis. We type in 2 divided by 3. Close the parenthesis. Then you hit the raise to the button. Open another parenthesis, and we're going to do 6. Although it's really not really necessary for the 6, but to do parenthesis. And hit equals. So you get A of 7 is equal to 729 times, and we get this ugly decimal of 0.087791. Now, typically, if I have a graphing calculator, I would convert that decimal to a fraction because I like working with fractions better. But seeing I don't have a graphing calculator, I got to make do with what I have. Okay. Now, obviously, we're now going to take the 729 and times it by that ugly decimal. So I'm going to just do times on my calculator because I have that decimal already in the calculator. By 729, hit equals, and I get 64. So that means on the 7th day of their vacation, they only went 64 miles. Okay, so that's part 1. Part 2 of this question's now asking you, all right, how many miles did they drive all together during their vacation? So that is the summation formula or series of this equation. Okay, that says you're going to do a of 1 times, remember this is the really ugly fraction here. You're going to have 1 minus r to the nth all over 1 minus r. Alright, so here we go. These people went 7 days, so S of 7 equals A1, 729, times 1 minus 2/3 raised to the 7th power, all divided by 1 minus 2/3. So I'm just going to start setting this part up, the outside part, that's the easy stuff. Now again, remember, order of operations says we have to do the 2/3 to the 7th power first. So open a parenthesis, 2 divided by 3 on the calculator, raised to the, and obviously we're going to go to the 7th power and hit equals. Might have to move this out of here real quick. Fit this decimal in. So we're going to have 0.0585528 divided by 1 minus 2/3. I'm going to have to shrink this down a smidge so we have more room. There we go. Alright, so now we have to still stay on the top. Don't go down to the bottom yet. Stay on the top. Okay. So we're going to do S of 7 equals 729 times, now we're going to subtract this. So on your calculator, you can do 1 minus the previous answer. Oh, 5, 8, 528. I get point. I might need to move that again. 0.941472 divided by 1 minus 2/3. Alright, now we gotta do the bottom. Now what I would do, since you already have this in your calculator, what I would do is just keep that there and just immediately hit divided by, open a one parenthesis to start, Then you're going to do 1 minus, open another parenthesis, and then do 2 divided by 3. So on your calculator, for the bottom, you're basically doing this. Open the parenthesis, 1 minus, open another parenthesis, 2 divided by 3, close parenthesis again. That way it takes care of everything, and you can do all your math at once. So now, I hit the equals. Alright, so, when I do this out, I'm going to have s of 7 is equal to, I get 729 times 2.824416. Now I times by 729, and you're going to find your calculator, s of 7 is equal to 2058.999264. This is why I don't like using the decimals. I would rather use fractions, because obviously looking at this, most of you could probably figure out that it was really, if I used fractions, going to be a nice number. S of 7 is equal to 2,059 miles. Oh, miles. Okay. Now a lot of you can see why I don't like using decimals. I'd rather use fractions, because it would have come out nice rather than having this extra garbage here that we didn't really need. Alright, on to the next one. Alright, next question says, find the sum of all the even integers from 1 to 999. Alright, now this one is not as tricky as it looks. Okay, but it does have a nasty little trap for you if you are not careful. Okay, the biggest thing I see here that we are going to have to worry about is this. It said even integers. Okay, but notice they give you a 1, which is an odd number, and they give you 999, also an odd number. Okay, so we have to be very careful. Now, starting off, we have to think, is this arithmetic or is this geometric? Now, some people would say, well, it's easily geometric because it's evens, but it's not. Again, thinking of timesing by 2 is not the same as adding 2. When you're doing even numbers, you are adding 2 every single time. So this is an arithmetic function. Okay? So, let's start off. First off, we have to have our a of n, our a of 1. Our first term of the sequence. And it's not 1, remember. 1's an odd number. So we have to go to the next one up, which would obviously be 2. We then have to think about our last term of the sequence. Now, I don't know how many terms there are in this sequence. I can probably easily guess. But last term of the sequence is not 999. I have to go 1 down to stay in the range. So it is 998. Now again, people ask me all the time, well, gee, shouldn't I do 1,000? No, because we are asked to stay within the confines of between 1 and 999. 1,000 would be over on the other side of where I'm supposed to be. So again, you have to go up and down the scale depending on what you're dealing with. Now, the other thing we have to figure out is our distance. Now, this should be pretty simple. Just like our consecutive integer problems way back at the beginning of the year of school, remember, evens and odds follow the same pattern. Whether you're going from 1 to 3 to 5 to 7 to 9, or you're going 2 to 4 to 6 to 8 to 10, we are always adding 2. Now, so we're looking at this. There's one key thing I'm missing. I need to know the number of terms in the sequence. So we are going to start with our arithmetic formula, so our a of n equaling a1 plus n minus 1 times distance. Okay, and we're going to just go get n, the number of terms. So an, 998, equaling a1, 2, plus number of terms in the sequence I don't know, and my distance is going to be 2. Alright, so now let's distribute this in. So I'm going to take this 2 and send it inwards. Whoops. So we're going to have 998 equaling to 2 plus 2n minus 2. We then need to combine our like terms here. So again, my like terms are this and this. So if I take positive 2 and subtract 2, these completely cancel. So I'm left with 998 is equal to 2n. So when I divide by 2, n is going to equal to 499. So there are 499 terms in the sequence. That's great, but that's not what we're asking for here. It wanted to know the sum of these integers. So again, just like before, here, let me shrink this down a little bit and scooch it over here. So just like before, okay, we're going to have to use our summation formula. Okay, so our S of n equals n times a1 plus an divided by 2. Alright, so we're going to have S of, we found to be 499 terms here. Make that look, there we go. Equals 499 times a1, first term of the sequence is a 2, plus an, 998, divided by 2. So S of 499 equals 499 times 1,000 divided by 2. Alright, so S of 499. Sure, most of us can do this part without the calculator. 1,000 divided by 2 is 500. And then I times it out. So S of 499 is equal to 249,500. So there's our sum. That's what we're looking for here. Alright, so that is the end of this video. So hopefully you've learned a lot from me, and again, now you can get started on your homework, so have fun with that, and I'll see you the next time.